least at the present moment, see or meet each other in person. Well, undoubtedly, e-technology helps in conveying what we want to convey to you, but the communication that is sent via the physical means is no compare with this e mode where neither the student nor the teacher is able to see each other. But what all we can say is uh, better than nothing. Well, let's try and have a little discussion with you. You have joined this institute. The mode of joining was a competitive examination called the West Bengal Joint Entrance Examination, which you have been able to, should I use your word, cracked. Probably you have got cracked this examination with fairly good rank, maybe something like 1000 or 1200. So to get this rank, you had to toil all the day with physics, chemistry, and mathematics. But now ask yourself, did you like physics, chemistry, and mathematics? Or just was physics, chemistry, and mathematics a means for an end, that is, a fine rank in JEE? Well, none of us do work which has no effect with the result. But looking at the result only and trying to do a job may sometimes be detrimental. Mostly, what happens for you is when you try to crack these examinations, especially the mathematics and physics parts, you have to use a large number of tricks. Let us not exemplify them here. And in the process, you get bored. If not bored, some of you even get burnt out. Now, you are joining the institute to study something you have got by a product of hard labor. Will this burnt out or half burnt out phase of thinking be nice for you? I don't think so. Now, this is one of the big impediments, and you must be aware of it. Now, once you have joined the institute, you have to study the subject of your choice, which in this case is mechanical engineering. Are you going to study just for study's sake? You will say, no, no, no. I have taken up the subject because there are at least some employment opportunities or job opportunities which I will get after I graduate or pass out from the doors of the institute. Yes, very much agreeable that none of us are like the respected and talented mathematician Ramanujam. He never cared for his health. He never cared for eating. He never even cared for the wellness of his body. He died out of fierce diseases, but he would love mathematics. That was his end for life. That is, however, for any of us, it is not the case. Undoubtedly, a job and a means of employment is important, but just a means for an end, that is, the need for a job, cannot be why we study. Then we would better call it studying for no interest. And once you get into this idea, you will get into a dual cycle. A student who has no interest will say, I don't study because I have already got a job. If I have got a job, which is my objective in life, why should I study? And the second group will say, I have got no job, why should I study? So, the purpose of studying, if be just a job, then the person who has got a job and who has no job or no job offer both of them will say, well, I will not study, because in either case, in one case the goal is reached, in other case the goal is not reached. And if you go on doing this, you will go into a cycle of wrong and demotivating state of affairs, which should not be in any case agreeable, or as teachers, we should never recommend these ways of thinking to you. But the better and the appropriate way of thinking is, well, very well, you have got a job. What do you want out of the job? Well, the answer immediately is pay. Yes, pay is important, but along with it comes another aspect of the job, which is satisfaction. Do not forget that this second aspect is connected with knowledge and interest of the work you are doing in that job. Just think of an example. You have been offered a job which is having a sufficiently acceptable pay, and you are asked to sit in a chair doing almost nothing for 8 hours a day. How long will you be able to continue with that job with a smiling face? I think the vast majority, 80 to 90% of you, will immediately answer saying, well, that is just impossible. I have to quit. Why? Why are you saying that you have to quit? The answer is, you have nothing to do, and that state of affairs is not acceptable, even though the pay may be quite acceptable. So, along with a handy or a satisfactory pay, you need a satisfactory level of job satisfaction, because if you do not have it, you will not be able to sustain the job for your whole life. And please understand, just as you need a nice family to lead a nice life, you need a nice job, or better to say, a nice profession where you will have a nice pay and a nice intellectual satisfaction to continue happily in life. If you think it this way, you will not get into the dichotomy, and you will not get confused in your life. That is rather the way we would like you to think. And if you have to think that way, you have to have a liking for the subject which you have, in whatever way possible, selected as the possible career for your lifetime. Now, a second question what we would be asking to you is, why are you studying engineering? And then, why have you chosen to study mechanical engineering? Well, the first question, why have you chosen engineering? Is it because you have inclination for engineering? I doubt. Many of you may start saying, my parents told me, if you study physics, chemistry, mathematics, or say English language, or what we say, economics, you may not get a quick job. And since you will not get a quick job, you will not be able to sustain. So the answer was again a, a fairly acceptable job opportunity. Now ask yourself then, that once you have entered engineering, why did you enter mechanical engineering? Well, many of you will again give a nice answer. I sat in that competitive examination and I got a rank, and the rank was such that mechanical engineering was my option. Had I got computer science or electronics, I would not have opted for mechanical engineering. Your answer is very much acceptable. But at this present point of time, you have no other option with you rather than accepting what you have got. Now, if you have accepted what you have got, the question is, The basic choice also was not clearly yours, and the acceptance has to be from your end. So, whatever may be the state of affairs, you have landed into mechanical engineering. Be it your choice, be it your parent choice, be it your internal desire, or the product of the rank you got. But in any case, you have landed up here. So, better accept it as I was telling you and go ahead, because if you do not accept it, then again you go back to the stage of reappearing in joint entrance examination or rethinking about your career. Well, if you want to do so, you can very well do right at this moment, but do not start vacillating once you have started studying the subject. That would be still bad. Now, what we want to first tell you is, well, you have landed upon in mechanical engineering. Do you have any idea of what is mechanical engineering or what is the role of a mechanical engineer? All of us know what is the role of a doctor, be it a medicinal doctor or a surgical doctor. We know it. But do you have any idea of what is the role of a mechanical engineer or what is a mechanical engineer supposed to do? The answer is, well, mechanical engineering is the science of designing, constructing, and then fault detecting and maintaining of machinery. Defining machinery is not my job here. It would be done in courses that you would be studying. But with your common sense knowledge, I think you will be able to understand this statement, what design, construct, and fault detection and maintenance of machinery means. Well, to start giving an example, suppose you want a heavy load to be carried up on a staircase by a machine. Well, you may call the machine as a robot, or you may call it as something else we are not interested in. So the machine is not existing. First, the machine has to come into your mind. Then, the drawing of the machine should come into a paper. Once you have made a sketch of that machine on the paper, next you want to know what would be the dimensions of the machine so that it will function well. So that is, so these 3 points, that is bringing the machine into your mind, drawing or sketching a picture of it, and then knowing the dimensions of it and the detailed intricacies of it is what is called design. So, design is the process by which the machine comes on a piece of paper. Now, translating what you have on a piece of paper into a reality. Reality means it is a process by which you construct or manufacture a machine. So the machine comes into reality. That is step 2, what we call construction or manufacture the machine from what was there on paper to the real object. The third step is machine has started working. Well, it may and will possibly have faults, and you will have to rectify it. First, as an engineer, in many of the cases, we need to know well ahead of time that the machine is developing a fault. This is called predictive fault detection. The other fault detection is Well, the machine has stopped functioning. There is some problem in the machine, and that needs to be stopped and maintained. That is called breakdown maintenance. So the first one is called predictive maintenance. The second one is called breakdown maintenance. And there is also a third option in which an engineer has by experience fixed a certain interval of time at which the machine will have to be stopped and has to be overhauled and maintained so that faults do not appear in the machine. That is called routine maintenance. Among all these three, the most difficult and challenging is predictive maintenance. All process plants today which work for 24 hours, like steel industries, like power plants, which give the power at your home, these process industry machinery work for 24 hours a day, and most of them require predictive maintenance. The engineer there needs to know that there will be a possible fault, and knowing the fault a priori, he will take corrective measure. The reason of this scientific method of maintenance over and above the other two is due to the fact that in cases where you go for routine maintenance, you stop the machinery unwantedly. So a power plant stopped unnecessarily or unwantedly at regular intervals will result in heavy loss of money. No one wants it. And breakdown maintenance is also another undesirable process because once a machine breaks down, the cost of maintenance is high. So, the most appropriate maintenance is predictive maintenance or maintenance as and when required. An engineer needs to be more skilled, more knowledgeable in his job to diagnose such problems. So, to come back as a mechanical engineer, what you need to do is design, construct or manufacture, and then fault detect and maintain machinery. Next, the question is machinery is a vague word. Well, we are not going to discuss in this introductory discussion about what a machine is, but what we would like to tell you is whatever may be the idea of a machine in your mind, well, you will understand that the word embraces a vast world of reality. So, if we go to a bullock cart, well, that is a machine. You have a wheel, the wheel is connected to the cart by a bearing. All of these are machine elements of or parts of machine. To a modern sophisticated car made by what we say Mercedes Benz, BMW, etc. They are also machinery. And why do we go and stop our examples in automobiles? Railways, railway engines, aircrafts, ocean liners, all of them are big machineries. And though you may think that ocean liners or aeroplanes are under the purview of marine engineers or or aeronautical engineers, well, in a larger or a more broad-based way of thinking, all of these very well fall in a generalized domain of mechanical engineering. So, whether you have liked it or whether you have not liked it, whether you have to make made your choice about mechanical engineering knowingly or unknowingly does not matter. You have embarked on a career in which you will have to get yourself acquainted with a vast number of opportunities of machinery that human civilization meets in life. Let us not try to give more examples and unduly lengthen our discussion. Once again, it is a one-way traffic because you cannot talk to me. I can only give you my recorded voice. Anyway, so what is the conclusion? Mechanical engineering is vast and it embraces a large or a diverse set of machines. Well, here we should not stop. Mechanical engineering, which we studied when we were students 30 years back, is not the mechanical engineering you are supposed to study now. Now mechanical engineering has become more and more an interdisciplinary thing. Well, let us give a simple example. See, many of you might have been acquainted with small blood pressure instruments at your home which checks blood pressure of a human being. Well, it is a very small piece of instrument, but this instrument has within it a sensor which is able to sense some aspects of it which will help you understand the blood pressure, and in all probability I guess that is your pulse. Second, the machine must have a compressor in a very small form which helps raise the air pressure. Now, and in between you have a nice complicated electrical or electronic circuit. Now what have you seen? Electrical science is getting coupled with mechanical engineering, or electrical engineering and electronics is getting coupled with mechanical engineering. So at the international level, you will see there are many institutes which give courses in this coupled field which is called mechatronics. Mechatronics is a field which stems from electrical engineering, electronics engineering, and mechanical engineering, or is a concoction or mixture of all of them. Well, why only just take up this? Cars 30 years back, which had internal combustion engines, specifically petrol engines, used to use a carburetor, a device which was required to feed petrol into the combustion chamber of the engine. No modern car uses an engine which employs a carburetor. We have an MPFI, multi-point fuel injection. With the MPFI goes or is connected a electronic circuit with a computer chip. Now, what then is MPFI? It is a mechatronic product. So, 30 years back, mechanical engineers had to know electrical engineering because of their job need. But now today, it is many times more true that as mechanical engineers, you also need to know parts of electrical and electronics engineering, especially computer languages, which will be able to go to a lower domain or low level to actuate and control machinery, and as well as you need to know chip level electronics so that you can employ these ICs to get your job done. So in near future, if not even today, mechanical engineers need to know all of these. So adding to your interest, you will see mechanical engineering is that vast that portions of electrical, electronics, and relevant portions of computer science also need to be known by a mechanical engineer who is supposed to embark upon a career in the present context. Now, after giving you a introduction or probably trying to sketch about what a mechanical engineer needs to do or know, well, you will very well be interested about your job prospects, because after all, that is what you have, what that is the final goal for which you are studying all this. Well, to just give you some idea, most of your campus placements start in third year first semester, at the end of this third year first semester, and goes up to the last semester, that is fourth year second semester. And in many of the cases, most of the students go for an internship, and and during internship, if you do well with a fairly nice company, you have fair chances of getting a pre-placement offer, which will, and therefore you are going to have a job to start with when you are leaving the gate of this department or university. So this is regarding campus placement. See, the next point is, many of you will say, well, we are interested in higher studies. Well, if you are interested in higher studies, you can go for a higher study in the form of masters and or PhD. But there are some students who also go to study management after completion of their course or graduation course here. Regarding prospects of management or prospects of job of management, well, that is not my job here, or that is rather not what we want to deal with. But what we can tell you is, you can always go for a master's and a PhD during, after you complete your graduation, for careers in, well, in research organization, or well, some of you may again try to come back into the profession of teaching the subject as we are, and for that you need a higher qualification in the form of a master's or a PhD. But there are also many students who join research organizations after, either after completion of their master's or PhD, or some of these research organizations may even recruit graduate engineers and give you scope for continuing with your master's PhD. And such organizations are of two types, either government organizations or non-government organizations. Under government organizations, you may have DRDO, CSIR. Under CSIR, you will have CMERI, ISRO, DAE, and so on. And under non-government organization, you may have TRDC, TRDC, and well, design and CAD divisions of various multinational corporations which do many CAD modeling activities in this country. Or if some of you prefer to leave this country, well, very well, there are opportunities as graduate mechanical engineers for masters and PhD abroad. However, we are not going to further detail upon these issues in our introductory discussion with you. Well, then next point is, what is the curriculum or structure of the curriculum that you will study here? Well, the subjects are maybe large in number, but they are classified into the following categories. Number one, humanities and social sciences. You have one or two papers in which you will have a brushing up of your knowledge of English for technical communication, and you need to study a little bit of sociology as well, where probably you will be introduced to the history of industrial revolution and how engineering comes in view. Well, to study history of engineering and mechanical engineering, which will not be done in sociology, is a very attractive field. But unfortunately, the this subject should have been given as an elective itself in by our department, but presently we do not have it. However, you are all intelligent students. We can give you books. You have your internet. You can, when you are about to study mechanical engineering or start your career in mechanical engineering, you should very well know about the history of mechanical engineering, because once you do so, you will be able to know about its goals and how the subject evolved practically from situations 500 or 600 years back. The second group would be basic sciences. For mechanical engineering, you will have to study mathematics and physics, which you have done in your plus 2. But what we would like to tell you is, you have just one paper. While you have just one paper in physics, you have about four papers in mathematics. Please, for heaven's sake, do not neglect mathematics. Even if sometimes you see classes are irregular, you will very well have the syllabus with you. And since the subject has been studied or is supposed to be studied by you up to your higher secondary course in sufficient detail, do not lose contact with it. Do not start thinking that mathematics is not relevant to the for mechanical engineers. Please give due weightage to it, because many of you who would either study masters, PhD, or even management require knowledge of mathematics to a sufficient level to do well there. So what I would like to request you is, give high importance to mathematics as a science, as a subject of basic science. The third group involves subjects which are basic sciences of mechanical engineering itself. They are solid mechanics, fluid mechanics, thermodynamics, and heat transfer. So far I know these are the four subjects, that is solid mechanics, fluid mechanics, thermodynamics, and heat transfer are the four basic sciences or four basic pillars on which the science of mechanical engineering rests. And once you have studied these subjects well, you will go into the true mechanical engineering subjects or applied mechanical engineering subjects, which include manufacturing using machine tools or non machine tool manufacturing like casting, forging, press working, so on and so forth, which will be taught to you by our production engineering specialization. You will get to know about hydraulic machinery, and the same will be taught to you by the fluid mechanics specialization, in which you will get to know about fluid handling machines, a large number of them. You will get to know about thermal machinery by the teachers of our heat power specialization, and that includes engines, turbines, compressors, and other thermal machinery. So these are applied engineering subjects, and to study this you require a firm knowledge of the sciences of mechanical engineering, and along with it you need to do the laboratories well, because please understand, as a physicist, one studies IC engine in an honors course, but the study of IC engine as a student of physics and study of IC engine as a student of mechanical engineering is vastly different. While the student of physics will just go into the principles of operation of an IC engine, as mechanical engineers, you need to know each and every part of an IC engine, not just its vague operation, because it is for you as mechanical engineers, to rectify an erroneous IC engine, to improve the design of an existing IC engine, and so on and so forth. So your knowledge has to be many times more detailed than the knowledge of IC engine by a student of physics. By this again you will be able to get a little of smell about what an engineer is supposed to do. The last is the machine design specialization. The machine design specialization will teach to you kinematics and design of machinery. Well, kinematics of machine is a way by which you are going to bring the machinery or sketch the machinery you want into the form of a sketch in a paper with a pencil. And in the design of machinery, what you are expected to do is to provide exact dimensions of the machine based on principles of the basic sciences what you have been taught earlier to 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 satisfy the end. So here the machine design specialization is supposed to use the basic sciences for 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 constructing the machinery from the imagination. So from imagination to a sketch on a paper, from sketch on a paper to manufacture the machine. This is within the ambit of the machine design specialization, which is a very important specialization for us. Well, as a vague analogy, we can tell you the science of medicine to a doctor is analogous to machine design for a mechanical engineer. So you are very well acquainted with the four steps, that is, first humanities, second basic sciences, third basic mechanical engineering sciences, fourth actual engineering subject. The fifth group would be, since as I had been telling you, interdisciplinary subjects are on the rise, you will have one paper of electrical engineering and one paper of electronics. Please do not neglect them. And the last would be, you will have a little of a study of management, which for many of you may be a career at the end, because after you complete your graduation here, if you go into a management career, you will have a small smell of industrial management in a complete paper which will be taught to you during this coursework. The next is the examination system. Well, COVID has, and the present lifestyle has spoiled the education system and the evaluation system sufficiently. Well, as you are hearing to me as a one sided discussion method of discussion, neither you are able to interact, or you are neither able to see me in flesh and blood. In the same way, examination systems like the teaching system has got should I say devalued. Well, in the original system for us, had there been physical classes, you had to appear in two class tests and one semester examination for all theoretical subjects, and for all sessional subjects you have continuous evaluation followed by a viva voce, either during the end or throughout the semester for evaluation of such sessional subjects. Regarding the evaluation process during the COVID times, you will be informed to you by your teachers as and when necessary. After all, we all hope we will soon be able to come out of this unnatural condition soon. The last, to remind you what to be careful about. Well, first, as one of my teachers told you, you are studying mechanical engineering. Mechanical engineering is vast. Do not go suddenly to say, I like this paper, I do not like this paper. Do not start getting in love with special papers. As one of my respected teachers told me, special paper is your toilet paper. Learn nuts and bolts engineering. What he meant is learn or have sufficient level of knowledge of all subjects of mechanical engineering, and do not say this is unimportant, that is not required. All is required. Second, do not neglect maths. Do not neglect non-departmental subjects of electrical sciences and electronics. You are probably going to walk into an era in which interdisciplinary subjects will rule the roost. I think the way we have discussed is sufficiently elaborate. We should not speak more on the first dose, and I think we should call an end to the present discussion, or should I say present lecture better, because this is one sided and unfortunately you are unable to interact with me. Hope we are out of the COVID situation, soon back to the university where we will be able to meet each other. Once again, we would give you, the coming first year students, a warm welcome. Thank you.